Today we're going to talk about Lesson 5-3, Solving Systems Using Substitution. Now, some of you should be familiar with this. Why? We talked about this in Algebra 1, substituting one equation in for another. If you remember, a system is just simply a set, a bracket with two or more equations. So maybe something like this. Okay? And what we would do is look for the equation that is solved for a single variable. So in this case, y is solved for by itself. And then wherever we see y, up in this one, we would put in x plus 5. Once we have it down to one variable, then we're able to solve for that variable. So let's look at example 1. Abel Baker makes a total of 160 dozen regular muffins, mini muffins, and jumbo muffins for his stores each day. He makes twice as many regular muffins as mini muffins, and 5 times as many jumbo muffins as mini muffins. How many of each does he make? So, we have, if you notice, regular muffins, mini muffins, and we have jumbo muffins. So we have 3 different kinds of muffins. So since we have 3 different kinds of muffins, we have to have 3 different equations. Okay? So the first equation is we know that all the regular muffins, mini muffins, and jumbo muffins together has to equal a total of 160. So R plus M plus J has to equal 160. Okay? So that sentence is done. It says he makes twice as many regular muffins as mini muffins. Makes twice as many regular muffins as mini muffins. Well, how would you write that as an equation? How do you say twice as many regular than mini? Okay. Well, my regular then is equal to, my regular muffins is equal to twice as many mini muffins. It says twice as many mini muffins. Okay. So my regular is equal to twice as many mini muffins. Okay. And 5 times as many jumbo muffins as mini muffins. So my jumbo muffins are equal to 5 times as many mini muffins. Okay, so if you look here, I got 3 equations, I got 3 variables, so I should be good. If you look here, R is in terms of M, J is in terms of M. So what I can do is I can replace R up here in this equation with 2M. I can replace J up here with 5M. And then we'll have all M's across here. So I'm going to substitute these 2 equations into the first one. So R, what's R? R is 2M. Plus M, I still have that, that's 1M, plus J, which is 5M, equals 160. Now you notice I have it all in terms of one variable. If I have it all in terms of one variable, I can solve for one variable. So 2M plus 1M plus 5M, 7 plus 1 is 8M, equals 160. I divide by 8. And M equals 20. Okay? So now that I know M is 20, I know I made 20 dozen mini muffins. How many regular muffins did I make? Well, 2 times M. What's M? 20. So I make 40 regular. And how many of the jumbo? 5 times 20, which is 100. Now, if I add all these up, they had better equal 160, otherwise I did something totally wrong. Well, 40 plus 100 is 140, plus 20 is 160. So, we did this correct. Example 2, it says solve this system. The system of equations is y equals 4x and x times y equals 36. Okay? So, what we are going to do here, I'm looking for the equation that has one variable by itself. Well, this equation has one variable by itself. So I'm going to substitute this equation into this equation. So wherever I see a y, you put in 4x in the second equation. Okay? So, x times y, well, what's y? Y is 4x equals 36. Yeah, it's no different than someone telling you what something is and you just plug it in. Okay? Well, what's x times 4x? Well, you would say 4x squared equals 36. I still need to get x by itself, so I need to divide by 4. When I divide by 4, I'm left with x squared equals 36 divided by 4 is 9. How do I get x by itself? Well, I take the square root, because I have x squared, so to get x by itself, I have to take the square root. When I take the square root, x is going to equal plus or minus, don't forget that, plus or minus 3. So you have two solutions to this problem. It could be positive 3 or it could be a negative 3. Okay? Consistent and inconsistent systems. A system that has one or more solutions is called a consistent system. Examples 1 and 2 involve consistent systems. We found one or two solutions. A system that has no solutions is called an inconsistent system. Example 3 is going to illustrate that for us. So if you look at example 3, once again, solve the system of equations. We have this right here. I'm looking for the equation where one variable is set equal to something. Well, if you look up here, the top one, it says x equals. Okay, so I'm going to take the top one, plug it into the bottom. So wherever I see an x in the second equation, I put in 4 minus 3y. So 2 times x. What's x? Well, x is 4 minus 3y. Plus 6y equals a negative 2. And that's what a lot of people have a hard time doing. You just rewrite this second equation. The only difference is you're putting whatever you solved for into that letter. So, same process as we've always done. You got to get rid of the parentheses. So 2 times 4 is 8. This is a distributive property. 2 times a negative 3 is a negative 6y. Okay. Plus 6y equals a negative 2. Have confidence in your mathematics. If you notice, my 6 y's are going to add out. Leaves me with 8 equals a negative 2. Is this true? No, not true. 8 cannot equal a negative 2. Therefore, there are no solutions. Or what they call is an inconsistent system. Okay? Have faith in your mathematics that it's all going to work out. Example 4. Solve this system. Once again, all these are solved for one variable. Okay? There might be times where it's not solved for you and you need to solve for a variable, which is fine. So here, wherever I see a y down below, I'm going to put in a negative 3x plus 2. So rewrite that second equation, 15x plus 5 times the quantity, negative 3x plus 2. All that has to equal 10. Okay? Get rid of your distributive property. 5 times the negative 3x is a negative 15x. 5 times a positive 2, a positive 10, equals 10. Have faith in your math. Your 15x's are going to add out. Leaves me with 10 equals 10. Is that true? Yes, that is true. So, if they equal each other, we have infinite number of solutions. That means they lie on top of each other. Okay? We have two lines that lie on top of each other, which means every single solution works, and this is a consistent system. That's all I have for you today. Please enjoy. We'll see you tomorrow.